Let's take a look at our first problem. Got negative 3 plus 4 and plus 9. And this is combining numbers together, where you got positives and negatives. And order operations just says you handle it from left to right. So we'll do these first two. These first numbers. It's getting kind of late. Brain shutting down. Okay, this is the case where we had different signs. Remember, in different signs, you ignore the signs. So we'd have 3 and 4. Subtract the smaller from larger. 4 minus 3 gives you 1. And the sign of our answer is sign of the larger number. Larger number is 4, which would be a positive. So we got positive 1. I'll put it here just to emphasize it. And then we handle these. 1 plus 9 gives us 10. And that would be our answer. Our second one. We got negative 8 plus negative 6 plus 2. Well, to begin with, I can use a shortcut here. Plus parentheses minus becomes a minus. And again, order operations, we're going to handle this from left to right. So I'll do these for these two numbers. Now these have the same sign. So we ignore the signs. So I got 8 and 6. You add them. 8 plus 6 gives us 14. And sign of the answer is the original sign, and they originally were negative. So I got negative 14 plus 2. Okay, now I'm going to do these two. These are different signs. Different signs, we ignore the signs, so we got 14 and 2. Subtract the smaller from larger. 14 minus 2 is 12. And sign of the answer is the original sign of the larger number. Larger number is 14, which originally was negative. So our answer would be negative 12. Number 3. We got 72 plus negative 87 plus 5. Okay. We got a shortcut here. Plus parentheses negative, that becomes a minus. Remember, minus and negative are interchangeable. And then we'll do these from left to right. So these two numbers first. These are different signs. One's positive, one's negative. So we ignore the signs. We got 72 and 87. Subtract the smaller number from the larger number. 87 minus 72 is going to give us 15. And sign of the answer is sign of the original sign of the larger number, which is 87, which was negative. So we're going to have negative 15. And then I'll bring down the plus 5. Well, now we're going to do those two numbers. And again, the signs are different. So we ignore the signs. We got 15 and 5. Subtract the smaller from larger. 15 minus 5 gives us 10. And sign of your answer is the original sign of the larger number, which is 15, which was negative. So our answer is negative 10. Number 4. We got negative 61 plus 17 plus 97. Okay, again, we're going to do it from left to right. So handle these two numbers. This is different signs. One's positive, one's negative, so I ignore the signs. So I get 61 and 17. Subtract the smaller from larger. 61 minus 17 gives us 44, I think. Let me see, 3, 43, 44. And sign of your answer is the original sign of the larger number, which was 61, which was negative. So I got negative 44 plus 97. Well, now we're going to handle these two numbers. They're different signs, so I ignore the signs. I got 97 and 44. Subtract the smaller from larger. 97 minus 44 gives us 53. Yeah, 53. And sign of the answer is the original sign of the larger number, which is 97, which is positive. So we're going to have a positive 53. Number 5. We got negative 3 plus negative 2 plus 3. Well, to begin with, we got a shortcut here. We got negative 3 plus parentheses minus becomes a minus. And we have this to work with. Well, we'll handle it from left to right. So I do these two numbers. They're the same sign. So we ignore the signs. We got 3 and 2, and you add them together. 3 plus 2 is 5. And the sign of the answer is the original sign, which was negative. So we're going to have negative 5 plus 3. Well, now we're going to handle these two. And they're different signs. One's positive, one's negative. So we ignore the signs. I got 5 and 3. Subtract the smaller from larger. 5 minus 3 is 2. And the sign of the answer is the original sign of the larger number, which is 5, which was negative. So our answer is negative 2. Number 6. 7 minus 9. Well, these are different signs. One's positive and one's negative. So I ignore the signs. I got 7 and 9. Subtract the smaller from larger. 9 minus 7 gives us 2. And sign of the answer is the original sign of the larger number, which is 9, which was negative. So our answer is negative 2. Okay. Number 7. We got negative 5 plus 8 minus 8. Okay. Well, I'm going to look at these two numbers first. One's positive, one's negative, so I ignore the signs. I got 5 and 8. Subtract the smaller from larger. So 8 minus 5 is 3. And sign of the answer is the original sign of the larger number, which was 8, which is positive. So we got positive 3, and then I'll bring down to minus 8. Now we'll handle these two numbers. Again, they're different signs. One's positive, one's negative, so I ignore the signs. I got 3 and 8. Subtract smaller from larger. 8 minus 3 is 5. And sign of our answer is the original sign of the larger number, which was 8, which was negative. So our answer is negative 5. Problem number 8. We got negative 14 minus negative 5. Well, we can apply one of our shortcuts here. Negative, parentheses negative, becomes a positive. And now this right here, this is the case where we had different signs. So we ignore the signs. We got 14 and 5. Subtract the smaller from the larger. 14 minus 5 is 9. And the sign of our answer is the original sign of the larger number, which is 14, which was negative. So our answer is negative 9. Okay. Number 9. We got 82 plus 50 minus 15. Again, order operations, we handle this from left to right, so I do those first. And I don't have to worry about, these are both positive, I know how to do that. Watch me screw it up. 132, I think. 8, 9, 10, yeah. Minus 15. And this I already know too. 132 minus 15 gives us 117, I believe. And that'd be our answer. Okay, number 10. We got 2 times 2 plus 6 divided by 2. Please excuse my dear Aunt Sally. Please. There's no parentheses, no brackets. Please excuse exponents. There's no exponents. My dear, multiplication or division as I encounter either one from left to right. So the first one I run across is this one right here. 2 times 2 gives us 4. And I'll just bring everything else down. I'm still doing the my dear part, multiplication divisions. I counter either from left or right. Here's my next one, 6 divided by 2. That gives us 3. And then Aunt Sally. This is a PEMDAS. Please excuse my dear Aunt Sally. Aunt Sally, add or subtract from left from right. Well, 4 plus 3 is 7. That was our last thing we had to do there. So that would be our answer. Okay. Let's look at this one. Number 11. 5 times 1 minus 7 minus 1 inside of parentheses squared. Okay. Please excuse my dear Aunt Sally. Please. There's parentheses. Now it says do what's inside the parentheses. So we'll do that. 7 minus 1. Everything else carries down. So I got 5 times 1 minus 7 minus 1 is 6. So we'd have 6 squared. At that point, those parentheses aren't doing anything anymore, so I could drop them. That was the please part. Please excuse. The exponents is next. So I'm going to handle the 6 squared. Everything else carries down, so I got 5 times 1 minus 6 squared. 6 times 6 is 36. Please excuse my dear multiplication division as I encounter either one from left or right. So we got 5 times 1, which gives us 5, and then the rest of it carries down. Aunt Sally, addition, subtraction. Well, this is different signs. One's positive, one's negative, so I ignore the signs. So I got 36 and 5. Subtract the smaller from larger. 36 minus 5 is 31. And the sign of our answer is the original sign of the larger number, which is 36, which was negative. So our answer is negative 31. Let me go ahead and save this. Okay. FOA. Okay. Test 1. Review. Page 01. And it's our new page. Okay, let's look at number 12. We got 4 plus 5 squared divided by 3 minus 2 times 1. 4 plus 5 squared divided by 3 minus 2 times 1. Okay, please excuse my dear Aunt Sally. Okay, please do what's inside the parentheses. Here's parentheses. There's nothing to do inside of it, but actually those parentheses aren't even doing anything. So I could go ahead and drop those. So I got 4 plus 5 squared divided by. Now here we can actually do something inside of parentheses. 3 minus 2 is 1. At that point, those parentheses wouldn't be doing anything, so I could just drop them. Okay, that's the please part. Now, please doesn't actually mean get rid of parentheses. It says do what's inside the parentheses. But then again, if the parentheses aren't doing anything anymore, then you can drop them. Excuse, exponents. So I'm going to do 5 squared. So I got 4 plus 5 times 5 is 25. Divided by 1 times 1. Please excuse my dear multiplication divisions. I can count either one from left to right. Well, here's my first one, 25 divided by 1. So 25 divided by 1 is 25, and then I'll bring down everything else. My dear, I'm still doing the multiplication division, so here's the next one. 25 times 1 gives us 25. Aunt Sally, addition or subtraction? Well, 4 plus 25 gives us 29. And that's our answer. Number 13. 48 divided by 3 divided by, then inside of brackets, 20 divided by 5 close parentheses, divide by 4, bracket. Let me double check that. Lots of divides there. Divided by 20, divided by 5, divided by 4. Okay. It doesn't matter what it looks like. I'm just following my dear Aunt Sally. Please excuse my dear Aunt Sally. And again, please also means brackets. Well, here's brackets, so we're going to do what's inside the brackets. Now, with inside the brackets, we have parentheses. So I'm going to do that first. Here we got 20 divided by 5. So everything else carries down. 20 divided by 5 is 4, and those parentheses wouldn't be doing anything anymore, so I can drop them. And then it's divided by 4 carries down. Still doing what's inside the brackets, and there's only one thing left, 4 divided by 4. So we got 48 divided by 3, divided by 4 divided by 4 is 1, and those brackets wouldn't be doing anything, so I can drop them. Okay, now we're done with the please part. We did what's inside the brackets. Excuse, there's no exponents. My dear, multiplication and division is I count it from left to right. So here I do 48 divided by 3, which gives us 16. Still doing the my dear multiplication and division. Here's our next one. 16 divided by 1 gives us 16. And those will be your answers. 14. We got negative 21 divided by 3. Well, a negative divided by positive is negative, and 21 divided by 3 is 7. So our answer would be negative 7. That seemed too easy in the middle of those. Okay, number 15. We got 8 minus 8 divided by 1 times 6. Please excuse my dear Aunt Sally. Please. There's no parentheses or brackets. Excuse. Exponents. We don't have any exponents. My dear. Multiplication division is I can count either one from left to right. Well, here's our first one going from left to right. So I'm going to have 8 minus 8 divided by 1 is 8. And then I'll bring everything else down. Still on the my dear multiplication division part. Here's our next one. 8 times 6. So we're going to have 8 minus 48. Okay. We're done with the my dear Aunt Sally. Addition, subtraction. These will be my next two. One of them is positive, one of them is negative, so I'm going to ignore the signs. So I got 48 and 8. Subtract the smaller from larger. 48 minus 8 is 40. And the sign of our answer is the original sign of the larger number, which is 48, which is negative. So our answer will be negative 40. Okay, number 16. We've got 12 minus there we go. 12 minus 3 squared divided by 2 minus 1 times 1. First off, please excuse my dear Aunt Sally. I know something right away. There's nothing to do inside this parentheses, and those parentheses aren't even necessary. So I'll do 3 squared divided by. Please excuse my dear Aunt Sally. Do what's inside the parentheses. Well, there's my first thing. 2 minus 1 is 1. And at that point, those parentheses aren't doing anything, so I can drop them. Please excuse. Well, here's the next one. 3 squared. So we've got 12 minus 3 times 3 is 9, and everything else carries down. Please excuse my dear. Multiplication divisions, I count it from left to right. Here's my first one. So I got 12 minus 9 divided by 1 is 9, and everything else carries down. Multiplication divisions, you count it from left to right. Here's my next one. So I got 9 times 1, which gives us 9. And then the last thing is Aunt Sally, addition, subtraction, and this one we know already. 12 minus 9 gives us 3. And that's our answer. Okay, number 17. 32 over 40. Now this is simplifying a fraction, and I'll show you both ways. I'll show you the easy way first, if you can see it. We think the largest number divides into the number on top, numerator, number on the bottom, the denominator. And 32 and 40, largest number divides in both those is 8. 32 divided by 8 would give us 4. 40 divided by 8 is 5. So our answer would be 4/5. Now, even if you don't see the largest number divides into both of those, you can work your way through it. If, for example, you notice that this ends with 2 and this ends with 0, so you know they're both divisible by 2. 32 divided by 2 is 16. 40 divided by 2 is 20. At that point, you see this ends with 6, this ends with 0, so you know they're divisible by 2 again. 16 divided by 2 is 8. 20 divided by 2 is 10. And then again, you see these are both divisible by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. So if you don't actually see the largest number divides into both of them, no big deal. Just start working it, and it'll work out. Just as long as you see a number that divides into both of them. Okay. Another way to do this. If you're just not very good at seeing those patterns at all, do the prime factorization of each one. For example, 32. Start with my first prime, 2. It is divisible by 2. 2 times 16. 2's prime, so we circle it. We're still on a 2, and 16 is divisible by 2. 2 times 8. 2's prime, so we circle it. 8 is divisible by 2. 2 times 4. 2's prime, so we circle it. And 4 is 2 times 2. 2's prime, so we circle it, and 2's prime, so we circle it. So it looks like we got 5 2's. Now let's look at 40. Start with my first prime, which is 2. It is divisible by 2. 2 times 20. 2's prime, so we circle it. 20 is divisible by 2. 2 times 10. 2's prime, so we circle it. And 10 is divisible by 2. 2 times 5. 2's prime, so we circle it, and 5's prime, so we circle it. So we got 3 2's, and we got 1 5. Now after you do the prime factorization, then you're just looking for it to have in common. And so here's a 2, here's a 2. So those are going to cancel. Here's a 2, here's a 2, so those will cancel. So you got a 2 up on top, you got a 2 down below, you can cross them out. Here's a 2 and here's a 2, so those are going to cancel. And then we're left with 2 times 2 up on top, which is 4, and down below we're left with a 5, which would gives us 4/5. So different ways you can work them. I may not work all of them the long way like that last part, but that gives you an idea. Let's look at number 18. 12y over 32x. Let's start with our numbers first. I'm looking for the largest number divides into 12 and 32. And I believe that's 4. So 12 divided by 4 is 3, and y remains. 32 divided by 4 gives us 8, and the x remains. And that's our answer. Now, let me do it the longer way. 12. 12 is 2 times 6. 2's prime, so we circle it. 6 is 2 times 3. 2's prime, so we circle it, and 3's prime, so we circle it. So this top number will be 2 times 2 times 3 times y. 32 we already did up here. It's 5 2's. So we've got 1, 2, 3, 4, 5, and we also have an x down there. And again, we cancel what's alike. Here's a 2, here's a 2, so those cancel. Here's a 2, here's a 2, so those cancel. Oops. Let's try that again. There's no 3 down here. Okay, that looks like it, actually. So I'm left with a 3 up on top with a y, and down below I got 2 times 2 times 2, which is 8, with an x. And that would be our answer. We'll go ahead and save this page. Okay, let's start a new page. I guess we're ready for 19. Multiplying fractions. Got 4 over 3 times 5 over 18. Now remember, our first step for multiplying fractions is to simplify. So that's going to be our first step. Now with simplifying, you look for a number on top and a number on the bottom, and they both have to be divisible by the same number. For example, I see 4 and 18. Those are both divisible by 2. 4 divided by 2 is 2. 18 divided by 2 is 9. So we're left with 2 over 3 times 5 over 9. Now there's nothing else I can simplify here. We got a 2 here, but 3 and 9 doesn't work. Here's a 5, but 3 and 9 doesn't work. Now you might be looking at 3 and 9 and say, well, they're both divisible by 3. But remember, our guideline is one's on top, one's on the bottom. So then we're to step 2 in multiplying fractions. Multiply your top parts together. 2 times 5 is 10. Multiply your bottom parts together. 3 times 9 is 27. So our answer is 10/27. Number 20. 42 over 62. Um, 27 over 20. And 30 over 9. Same steps. First step is to simplify. The only guideline is one's on top, one's on the bottom. They don't have to be in the same fraction. Don't even have to be next to each other. One's on top, one's on the bottom. 20 and 30 are both divisible by 10. 20 divided by 10 is 2. 30 divided by 10 is 3. So we got 42 over 62 times 27 over 2 times 3 over 9. Okay. One's on top, one's on the bottom. Well, to begin with, I guess I could do this 3 and 9. They're both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. So we got 42 over 62 times 27 over 2 times 1 over 3. Well, here's a 27 and here's a 3. They're both divisible by 3. 3 divided by 3 is 1. 27 divided by 3 is 9. And let me continue the problem up here. So we got 42 over 62 times 9 over 2 times 1 over 1. Now when you have 1 over 1, you could actually drop that. I won't do that, but you could. Okay, 42 and 2. These are both divisible by 2. 2 divided by 2 is 1. 42 divided by 2 is 21. So we're going to have 21 over 62 times 9 over 1 times 1 over 1. Okay, well, I think that's actually it. Because 9 and 62, nothing in common. Because 9 is 3 times 3. And 62 is not divisible by 3. Because remember, if we add digits together, 6 plus 2 is 8. 3 doesn't go into 8. Now this is divisible by 3, but that doesn't help us because this is on top and this is on top. Now 21 is also divisible by 7, but 7 doesn't go into 62. So it looks like we're ready to go to step 2. Step 2 on multiplying fractions is multiply the top parts, multiply the bottom parts. Well, 1 times 9 is 9, times 21 is 189? Yeah, 189. Down here, 1 times 1 is 1, times 62 is 62. Unless it specifies otherwise, you want to leave it in just normal fraction form. In this case, improper fraction. Don't change it to a mixed number. Now that I said that, watch the key be a mixed number. But in general, you don't. Okay, let's look at 21. We've got negative 3x times 4x squared over negative 4 times Negative 3y over negative 2y. Okay. Well, to begin with, if you're going to multiply fractions together, they should all be fractions. So we'll put the negative 3x over 1 times 4x squared over negative 4 times, and here negative divided by negative is positive, so I can do a little bit of simplifying there. This will be 3y over 2y. Going along with that, look at my first fraction. It's negative. Second fraction, negative. Negative times a negative is positive, so I can go ahead and drop those negatives. So we got 3x over 1 times 4x squared over 4 times 3y over 2y. Okay, step 1. Wrong color, but oh well. There we go. If I ever get it right, there we go. Okay, do a little bit of simplifying. I'm looking for a number on top, a number on the bottom. Well, here's a 4 and here's a 4. That's easy. 4 divided by 4 is 1. 4 divided by 4 is 1. So we're going to have 3x over 1 times 1x squared, or just x squared, over 1 times 3y over 2y. Well, more numbers? No. Here's a 3 and 2. Here's a 3 and 2. Remember, our guideline is one's on top, one's on the bottom. But I do notice something. Notice we have y here and y here. So if you have the same on top and the bottom like that, they just cancel. Okay, so that is going to give us 3x over 1 times x squared over 1 times 3 over 2. Now we want to, we can't do any more simplifying, so we're going to step 2. Multiply your top parts together, multiply your bottom parts together. First thing we'll do is multiply numbers together. 3 times 3 is 9. Down the bottom here, 1 times 1 is 1, times 2 is 2. And our x's. You got x times x squared. We really haven't talked about that a whole lot. Basically, just count how many x's you have. There's 1x here, there's 2 x's here, so we're going to have 3 x's. Later on, we're going to see the formal property for that. So that would be our answer. Okay, let's look at number 22. (44 over 5 times 44. 24 over 5. Let's try it again. Times 66 over 42 times 14 over 33. Okay, step 1. Simplify before you multiply it together. So we're looking for a number on top, number on the bottom, and they're both divisible by the same number. Here's 66 and 33. They're both divisible by 33. 33 divided by 33 is 1. 66 divided by 33 is 2. So I got 24 over 5 times 2 over 42 times 14 over 1. Okay, looking for a number on top, number on the bottom. Doesn't matter, I guess. I'll choose this 24 and 42. They're both divisible by 6 at least, maybe more, but we'll go 6. 42 divided by 6 is 7. 24 divided by 6 is 4. So we're going to have 4 over 5 times 2 over 7 times 14 over 1. Let me double check my work here. I was kind of watching TV when I was doing that. Okay. Now again, looking for a number on top, number on the bottom. So number on top, number on the bottom. And they're both divisible by the same thing. 7 divided by 7 is 1. 14 divided by 7 is 2. So we've got 4/5 times 2 over 1 times 2 over 1. Well, there's not much more simplifying I can do there, so I'm ready for step 2 in multiplying fractions. We're going to multiply the top parts together. 4 times 2 is 8, times another 2 is 16. And we'll multiply bottom parts together. 5 times 1 times 1 is 5. So our answer will be 16/5. And let's look at 23. We got 35 over 2 divided by 14 over 3. We never actually do division. We immediately rewrite as multiplication. And how we do that is, of course, change it to multiplication, and then we flip the second fraction, one following the division symbol. When I say flip it, I mean take the reciprocal. Top goes to bottom, bottom goes to top. So 14 over 3 becomes 3 over 14. And now we're ready to go through our 2 steps for multiplying fractions. Again, we're looking for a number on top, a number on the bottom. Here's 35 and here's 14. Those are both divisible by 7. 35 divided by 7 is 5. Or 35 divided by 7 is 5. 14 divided by 7 is 2. So we have 5 over 2 times 3 over 2. Nothing else we can do simplifying wise, so we're ready to multiply them together. We'll multiply the top parts together. 5 times 3 is 15, and multiply the bottom parts together. 2 times 2 is 4. So our answer will be 15/4. And again, I'm pretty confident those aren't in mixed number form on the review key. Okay, 24. We got 17 over 22 divided by 50 over 11. We never actually divide. We want to rewrite it immediately as multiplication. So I got 17 over 22 times 11 over 50. And now we're ready to go through our steps. First step is simplify. Looking for a number on top, a number on the bottom that are both divisible by the same number. Here's 11 and 22. Those are both divisible by 11. 11 divided by 11 is 1. 22 divided by 11 is 2. So we have 17 over 2 times 1 over 50. Now 17 looks prime actually. 2 doesn't go into it, 3 doesn't go into it, 5 doesn't go into it. So we're ready to do step 2. Step 2 in multiplying fractions, you multiply the top part together. 17 times 1 is 17. Multiply the bottom part together. 2 times 50 gives us 100. So 17 over 100 is our answer. Let me save this page. And start a new page. There we go. And I guess we're ready. I think that was 24. We're ready for 25. You know, I guess I could actually read the directions. What do the directions say? Find the reduce the lowest term. Doesn't say anything about putting it in mixed number form. So, okay, negative 27. I have a bad habit of not reading instructions. Divide by negative 15 over 2. To begin with, again, if you're going to divide fractions, they both should be fractions. So I'm going to put the negative 27 over 1. You can always create a fraction by putting it over 1. We never actually divide fractions. We immediately rewrite as multiplication. So this will be negative 27 over 1 times, and then I take a reciprocal of this. Flip it. Top goes to bottom, bottom goes to top. So we got 2 over negative 15. Well, before I get into too much simplifying, negative times a negative is positive. So I can drop those negatives. We got 27 over 1 times 2 over 15. And we want to simplify that. And again, our guideline is one's on top, one's on bottom. You can divide both of them by the same number. Here's 27, 15, least both divisible by 3. 27 divided by 3 is 9. 15 divided by 3 is 5. So we're going to have 9 over 1 times 2 over 5. Now there's nothing else I can do simplifying wise, so I'm ready to multiply those together. 9 times 2 is 18. 1 times 5 is 5. So our answer is 18/5. If you've done a good job in step 1 in simplifying, there's no simplifying at the end. But you might just double check it to be on the safe side. Okay, 26. And actually, I'm going to grab a drink because I'm dying here. Okay. We've got 9/17 minus 5/17. Now remember our steps. Our first step was to get a common denominator. Well, that's done. Step 2 in adding or subtracting fractions is to add or subtract top parts, your numerators. 9 minus 5 is 4. And then your denominator stays as is. Step 3 was to simplify the fraction, but actually 4/17 we can't simplify. So that'd be your answer. 27. We got 1/4 plus 3/10 plus 1/3. Step 1. Step 1 says get a common denominator. Now to do that, we need to figure out what the LCM of 4, 10, and 3 is. So our first step in finding the LCM of those is to write prime factorization of each one down. Well, 4 is 2 times 2, 10 is 2 times 5, and 3 is 3. So then our second step in finding LCM is you take a look at each prime. I'll start with the 2. And we're looking for the greatest number of 2's on each single line. There's 2 here, 1 here, none here. So our greatest number of 2's on each single line is 2 of them. Then we go to our next prime, which is 3. And I'm looking for the greatest number of 3's on each single line. None here, 1 here. So we would have 1. Then I go to my last prime, the 5. And I'm looking for the greatest number of 5's on each single line. None here, 1 here, none here. So it'd be 1. 5 times 3 is 15, times 2 is 30, and then 60. 60, yeah. Okay, so 60 is our common denominator. Remember, the LCM becomes our common denominator. So I want to rewrite each of these fractions with our new denominator. Now you look at your old denominator and you ask, what did you multiply it by to get your new one? Well, 4 times 15 gives you 60, so we multiplied the bottom part by 15. So we have to multiply the top part by 15. On our second fraction, we went from 10 to 60, we multiplied the bottom part by 6. So we have to multiply the top part by 6. In our last fraction, we went from 3 to 60, we multiplied the bottom part by 20. So we have to multiply the top part by 20. Okay, 1 times 15 is 15, so we got 15 over 60, plus 3 times 6 is 18 over 60. 1 times 20 is 20 over 60. Step 2. Now that we got a common denominator, add all your top parts, or subtract, would depend upon what it is. 15 plus 18 is 33, plus 20 is 53. Let me double check that. 8, not 10, 3, 1, not, carry the not. Okay, yeah, 53. Now our last step is to simplify the fraction. And 53 looks prime. It's not divisible by 2, it's not divisible by 3 or 5, not by 7. Looks prime anyway. It's just getting late. That's our answer. Okay, number 28. We got 2/3 minus 2/6. Well, I noticed right away I could reduce the 2/6 and it becomes a fairly simple problem. So if you see that, fantastic. 2/3 minus 2 and 6, both divisible by 2. 2 divided by 2 is 1. 6 divided by 2 is 3. And at that point, we don't need to do step 1. They already got a common denominator. Step 2, add or subtract the top parts. 2 minus 1 is 1. So our answer would be 1/3. That seemed too easy. You could also got a common denominator, which would have been 6. 29. We got 3 minus 3/4. Just like before, anytime we're adding, subtracting, multiplying, or dividing fractions, they both should be fractions. So I'm going to put the 3 over 1. Now, whenever one of your denominators is 1, then your common denominator will always be the other one. So 4 is going to be our common denominator. So we're going to rewrite each fraction with that new denominator. Well, this one already has a 4, so I'll leave it alone. Our first fraction, we multiplied the bottom part by 4, so we have to multiply the top part by 4. So we got 3 times 4, which then gives us 12 over 4 minus 3 over 4. Now that's step 1. Get a common denominator. Step 2, add or subtract the top parts. 12 minus 3 is 9, and then the denominator stays 4. And we don't have to do step 3 because there's nothing to simplify in that one. Last problem. 4/6 minus 3/5. 4/6 minus 3/5. Interestingly enough, they threw another one in here we can simplify. 4/6, top and bottom both divisible by 2. 4 divided by 2 is 2. 6 divided by 2 is 3. Minus 3/5. Okay, we're working to get a common denominator. There's a little bit of a shortcut here. These are both primes, so you can just multiply these together, 3 times 5. But let me go through my steps, just to show you it works all the time. LCM of 3 and 5. Our first step is we write the prime factorization of each one down. 3's prime, so just 3. 5's prime, so just 5. Our LCM. Start with our first prime, 3. We're looking for the greatest number of 3's on a single line. There's 1 here, none here, so it'd be 1. Then I go to my 5. I'm looking for the greatest number of 5's on a single line. There's none here, 1 here, so it'd be 1, 5. So our LCM, or our least common denominator, would be 15. Okay. You look at your old denominator and you ask, what did you multiply by to get your new one? Well, our first fraction here, we had a 3, so we multiplied the bottom part by 5, so we have to multiply the top part by 5. Now in our second fraction, we multiply the bottom part by 3, so we multiply the top part by 3. Well, 2 times 5 is 10 over 15, minus 3 times 3 is 9 over 15. Now step 2. Add or subtract the top parts. 10 minus 9 is 1 over 15. And we still don't have to do step 3 because there's nothing to simplify there. So that'd be our answer. And I believe that was the last problem. Yes, it was. So let me save this video and then save that file.